Good morning and welcome to this session on lab innovation. The first two lectures have been organized by Spectaris, so a very warm welcome to the organization. And our first speaker is Dr. Melanie Kahl of Software AG, and she's going to talk about connecting lab devices, plug-and-play solutions with LADS OPC UA.
Thank you. So good morning, everyone, also from my side, and welcome to my presentation about LADS OPC UA. So my name is Melanie Kahl. I work as a consultant for lab automation at infoteam. And infoteam makes software for life science and medical products, especially in the regulated environments. But for myself, I'm not a software engineer, so my background is in life science and process engineering. I also specialize in the development of automated solutions, so both hardware and software, for applications in tissue engineering. I also have some experience in the quality assurance in the pharmaceutical industry. And now I'm promoting customized software for lab digitalization projects. So I have a quite diverse background in life science and engineering, so that is why I'm present you LADS more from a user perspective today, rather than from a technical perspective. So you're probably here because you're interested in a connected lab with automated data workflows from your analytical devices to your ELN or LIMS system. So you don't want manual data transfer anymore, maybe an app that guides you step by step through your workflows. Maybe you want remote supervision and control from your office space and receive instant alarms on your mobile phone when something is not working. Maybe you want automated reminders for cleaning and calibration tasks and audit trails on every device on your lab so that you don't need manual logbooks anymore. But why is that not working in your lab? Maybe it's because it's too expensive, or is it too complicated to install? So yes, that may be some reasons, but the main reason why automation in your lab is so difficult is that you have a lot of different devices in your lab which are highly specialized from different vendors and manufacturers. Some may be new, some may be old. And the problem is that these devices cannot communicate with each other, because often each device has its own proprietary interface, and which means each device speaks its own language. Also, each device produces data and analytical results in various data formats. Some have text-based results, like CSV or PDF, and some have also vendor-specific closed formats. So all these makes automation and digitalization in your lab complicated and cumbersome. So how can we address this problem? That is why we need a standard across different manufacturers. And that is why I introduce you to LADS today. So LADS is a communication standard for laboratory and analytical devices to ensure a uniform interface between all your equipment. So first I will demonstrate you a short introduction to LADS and how it's related to OPC UA, explain you how LADS interacts with other systems, and show you the benefits of LADS depending on the stakeholder and possible use cases with an inventory and variant process. So LADS stands for Laboratory and Analytical Device Standards. It's a communication protocol based on OPC UA and aims for the standardization of interfaces across different manufacturers to connect your lab device fleet. LADS was developed by a working group organized by Spectaris with over 40 manufacturers. They started in 2020 with possible use cases, concepts and specification, and it was just released end of last year. So as I already mentioned, LADS is based on OPC UA, so it's an official companion specification. As you might know, OPC UA is an established industry standard and with an architecture to describe and exchange machine data. Thereby, it's even more than a communication protocol because it also includes data models and interaction concepts. The main benefits of OPC UA its versatility and independence. So OPC UA itself is platform independent and supports various operating systems, just like Windows, Apple, Android, or Linux, and also runs on diverse hardware systems, including standard PCs, cloud-based servers, or microcontrollers. Also, cybersecurity is a core principle of OPC UA because it's embedded through a security by design approach and also ensures a top-down compatibility and agnostic design. And also compliance with regulatory requirements is a priority for OPC UA. So features like audit trails and data achieve an integral part and enhance its reliability. So all these features are also included in LADS. So because it's a companion specification. Similar to LADS, similar to OPC UA, LADS is also based on the EIC norm, just the same as OPC UA. So it's also compatible to OPC UA. But LADS is more specific to laboratory and analytical devices in regard to its data formats, functions, and parameters. And the main benefits are that it follows a best of breed approach, so that you can connect devices from different manufacturers into one system, and also has an agnostic design, so that future devices that you do not have yet can be integrated. So with this approach, LADS enables plug-and-play compatibility. Therefore, LADS aims to reduce the effort for the integration of equipment, for your quality assurance, for documentation and approval processes. But what is LADS actually doing? So it's a communication protocol. It's not a file or data format. It defines a rule of how to exchange information between two or more systems. So similar to your file structure on your computer, where you know where to find your PDF and Word documents, or your JPEG files in your pictures folder, LADS structures function, methods, and configurations of your lab device into similar groups. So that's called device type agnostic modeling, and thereby it provides generic patterns and rules so to integrate different types of instrumentations, and that the systems and devices can speak with each other. So, for example, if you look at a stirrer, which is quite simple, you have just two functions, to stir or cancel stir, and 3 parameters. But if you look at a HPLC, you have more functions, more parameters, and more methods. So that is all why parameter function information need to be categorized, which does LADS. So it makes it easy for other systems to recognize this information and to work with them. So how does it now work in context and the interplay with other systems? So each device has its own LADS client, and then you have maybe an ELN or a middleware, which has a LADS server as well. And via these LADS interface, the data, like process data, work instruction, parameter, alarms, are exchanged. And then with your ELN or system, you can do your sample tracking, data management, process data management, and so on, and also exchange these data with your LIMS or ERP systems, where you can store your data reports and audit trails. And if you have a little bit more sophisticated middleware, you can also do process monitoring, even remote monitoring and control. Also receive alarms and notification, perform a data analysis for predictive maintenance, and so on. So the middleware exchanges information with the devices via LADS, just input and output data, and thereby also expands the functionalities of a standard ELN. So for the plug-and-play compatibility, we need the hardware support of the devices, the software support, the LADS server, and with that, a consistent information structure, and then you can just add new devices to your system without changing your whole system. So who could be interested in LADS and who benefits from it. So in the lab, of course, we have a lab manager, technicians, and maybe the IT admin of your company. But also manufacturers might be interested, service technicians, LIMS officers, or maybe some hacker who wants to steal your data. But for now, we'll take a closer look on the upper three. So for the lab manager, LADS helps to maximize your productivity. You can optimize sequence of tasks and minimize bottlenecks, and thereby ensure a smooth information exchange. You can also plan more effectively your resources, that you may need less instruments, less manual steps, by having connected processes, and save costs and ensure better outcomes. By the automated data transfer, you reduce risk of human errors, enhance accuracy, and improve your data quality. With data analysis, you can perform predictive maintenance tasks and calibration so that you can repair and change systems before they break down, and thereby also avoid unnecessary maintenance costs. And of course, with the plug-and-play compatibility, you can seamlessly integrate new devices. You don't need to reprogram your software, your ELN system, and just scale up or change your processes without changing your whole IT system. For the lab technicians in the lab, first of all, you need less paperwork and manual documentation, because all essential information can be recorded. Like we have electronic forms and automated data entries, and digital signatures are supported. So this does not only save time, but also ensures accuracy. And thereby also the 4I principle can be eliminated. You can also supervise and control your processes from your office or even home office space, and receive instant alarm notification on your computer or mobile phone when something is not working or working wrong. You can also get calibration and cleaning reminders so that smart systems can track the calibration cycles and cleaning schedules, so they can receive automated reminders to ensure timely maintenance and cleaning. And you can also search and organize your historical data for easy retrieval, search protocols, reports, or any other relevant information in a well-structured database. And even for your IT admin, the work gets easier. So because of the simplified interface knowledge, the admins don't need extensive knowledge anymore about proprietary interfaces, because the LADS ensures a seamless communication across devices. They can access operational and device-related data easily, which allows quick retrieval and performance metrics, maintenance logs, and historical trends. You can easily exchange also devices between labs, swap them out, or defective devices. So, and yeah, you can just adapt as your system or your lab evolves. So how could now a smart process look like? So it's always an interplay between the user and the middleware. So in the office space, the user plans the experiment, chooses resources, defines materials and consumables, and the middleware can help and provide predefined templates. You can access historical data from previous experiments. Then the user goes into the lab and is guided through the process via a mobile app or smart assistant systems with lights, which minimizes errors and ensures compliance with standards and SOPs. And the middleware can here match the sample IDs via connection to your LIMS. So you can reconcile your sample numbers and ensure accurate traceability. The middleware can also configure your devices, so it can set your parameter, for example, like a speed and time for your centrifuge, so that you just need to put in your sample. Every process step is recorded with time step, so the device data, but also environmental data, temperature fluctuations, and reaction times. So the platform can record every detail you may need. Then the user goes back in the office where you can focus on data analysis, evaluation, review, and approval, because the middleware has already consolidated all the data, created reports, and prepared the data for archival and export. So about which data are we actually speaking about, and which data are exchanged between a device and an ELN? So if we look at an inventory process, we have maybe a fridge where we have the temperature, maybe when the last temperature mapping was performed, and alarms, and also maintenance data like cleaning and calibration tasks. Then you scan out a sample so that you know which sample was taken out, at which time, by which user, and also check with your system, was the right sample taken out, and how much of it do I need? And then on the scale, you can have also the process data again with the user time and the parameters. And then also check, was the calibration maybe performed before I put my sample on the scale? Was the right user input performed? And if you can go to a stirrer, we also have the process data again, and we can monitor the process, receive alarms and notification, or even change the process from your office. And then all these collected data can go into a report or audit trail and be stored in your LIMS. So now you have all the basics to connect your lab. Just to sum up what you just heard, so LADS provides a standardized interface. It's a communication protocol to have a consistent and standardized interface across your laboratory ecosystem. LADS enables plug and play, so connecting lab devices becomes straightforward as plugging in a USB drive. It allows a seamless compatibility. It reduces setup time so that you have a hassle-free device management. LADS also enables best of breed, so you can be vendor independent. And LADS bridges the gaps between processes, between devices, between lab and production areas with OPC UA, so it allows a seamless integration with existing workflows. And LADS supports a paperless lab, so you can do your data exchange, instrument control, result tracking, so that you can say goodbye to your paperwork and manual logs and get digital records and real-time reporting. So what are the next steps? So first, the lab device manufacturer need to integrate LADS clients into their devices. So by doing so, they empower labs with seamless connectivity, standardized interfaces, and enhanced functionality. For example, at the last LADS hackathon in Duisburg last month, we at infoteam helped a manufacturer to integrate a LADS client for a sensor device within 3 days. So it's not so complicated, and I think manufacturers are able to do this. And the laboratories need to be aware of the LADS interface, so they can plan and purchase new equipment with LADS. And then you can just buy the devices, which are LADS compatible, and plug them in and connect it to your lab network. So with that, I would like to thank you for your attention. If you have questions, you can ask me now, or if you have questions later, you can also go over there to the Spectaris booth and also meet us at Future Labs Live in 2 weeks in Basel.
Yeah, thank you very much, Dr. Kahl. Are there questions from the audience? Obviously, everything was quite clearly presented. But I have one question, because on one of your slides, it said that your solution can be easily integrated or made compliant with GMP requirements. How does it work? Does the software need to be certified somehow?
Yeah, so the software needs to be certified. I mean, it supports function like audit trails and data archival, electronic signatures, so that you can more easily stick to the GMP compliance.
I'm a layman, so please allow me another question. Does it require to publish or at least to reveal the source code to the authorities?
I have to check that in detail. Yeah.
Okay, thank you much. One question.
Thank you very much. If I hear from what you presented, it means that for any lab to key into this, it means you probably have to change all the equipment in your laboratory. Is there no way to sort of do something about some of the equipment you currently have to be able to get compatibility with this particular process?
So, yeah, it's possible. So, we actually do this also at infoteam. If you have old devices, you could also get an extra LADS interface to your old devices, which are just special, customized for you, and then you can also use LADS. Yeah.
Thank you. More questions? Yeah, then there we are. Thank you very much again for the lecture.